Hello, CS111 students. This is my video for the diamonds task, task 3 on problem set 2. And again, you do not need to watch this video. If you prefer to just read the problem set instructions, they're there, they're complete. All I'm doing is basically narrating them. So feel free to use this if you feel it's helpful, but it is not completely necessary. Go ahead and show you my screen where you can see the diamonds task already pulled up. This is kind of a fun or cute or puzzly little task. Um, it's going to help you think about how functions work and why functions are useful in the context of programming. And to do that, it's going to force you to jump through some artificial hoops. Um, so here is a pattern of output. You can see from this example that we were in the shell. We called the diamond pattern function. It has no parameters whatsoever, and it prints this pattern. And you might look at this and go, Peter, that seems a little bit tedious. For sure, I could write a function that printed that. I would just copy paste this pattern into Thonny and add a bunch of quotation marks and a bunch of print statements. And then it would do what you wanted, right? It's a zero argument function, doesn't return anything, just prints a bunch of output, simple. The trick is, we require you to write a program that does this using a specific pattern of function calls. And in particular, you are not allowed to call the print function in more than a certain number of places in your code. So, you're also not allowed to define your own strings. We have given you a starter file called diamonds.py, which is where you'll do the work for this task. It has these strings defined in it, and you're not allowed to use quotation marks to define any other strings except for the doc strings, because all of your functions have to be documented. But those aren't really going to be used as values in your program. They're just the documentation for your functions. So the diamond pattern function has to use only these strings to produce all of this output. And you're not allowed to use print in more than 10 places in your program. Now, there's a distinction here between how many times am I calling print, as in how many times did I write print in my source code, in my code, and how many times does my program call print. So to me, this is a distinction between procedure and process. The procedure is the instructions that we're following, and a restriction on the procedure says the instructions have to look like this. The process is what actually happens when we follow that procedure, and a restriction on the process says what has to happen must obey these rules. So what you see here, this is the pattern we have to produce. Now, the procedure for producing this pattern almost inevitably involves calling print a total of 1, 2, 3, 4, 5 times, because there's 5 lines in this row. 1, 2, 3, 4, 5, 6, 7, 8. 5 times 8 is 40 calls to print as part of the process. But just because there are 40 calls to print as part of the process does not mean there have to be 40 individual lines of code that say print on them. And so our requirement is that you can have no more than 10 lines of code that say print. And if you want to satisfy the extra goal, you have to get it down to just 5. But your process is always going to call print 40 times. Or sorry, your process is always going to involve calling print 40 times. Okay. We also have left this problem a little bit open-ended. You have to define a function called diamond pattern, and you're actually required to define some of your own functions besides that, but it's up to you what names to give them, whether they should have parameters or return values, or print something, or whatever you want to do, right? As long as in your entire file, print only appears 10 different places, and there are some restrictions on the function. So the diamond pattern function has to contain at least 2 function calls to custom functions that you have defined. Not built-ins like print or len, just a function that you define in the same file. Those 2 calls could be calls to the same function or calls to 2 different functions. It's up to you. And your diamond pattern function may not call print directly. So not only are you limited to 10 places in the code where print is called, none of those can be directly in the diamond pattern function. They have to be in these helper functions, these other functions that you write. So I've already gone through a lot of these things. Number one in the notes, everything you write has to be documented. You have to have a doc string. And we actually recommend that you write these descriptions of what the function is going to do before you write the function. So come up with an idea. Okay, I'm going to write a function that does this. Write that idea down as the documentation string, and then write the code that does it. Having that idea written down will help you refer back to it when you're writing the code and you're like, wait a second, should this function do this or that, right? You can refer back to that written idea, and it's super useful. It also helps you think strategically rather than trying to dive in and write a bunch of code and get tangled up. Another note here, there are possible solutions where one of the provided strings may not be necessary. So we've provided the strings 0, 1, 2, 3, and empty, and they each contain different values. Those are the only strings you're allowed to work with. You're not allowed to define your own strings using quotation marks besides those. But since these are variables and they're defined globally, any of your functions can use these. But this hint is saying, well, maybe not quite all of those are necessary in all solutions. Another note here, you're allowed to build larger strings out of those small strings, right? You're just not allowed to use quotation marks to make new strings with other stuff in them, right? So you're not allowed to just type in this whole pattern. And you're not allowed to use the new line character at all in any way. This note is something, again, that I have mentioned, right? Is like, you could invoke print 40 times and do this, but it would be boring. So you have to do at most 10, and as I have already mentioned, at most 5 times for full credit. And so using functions and the power of functions to call each other is how you're going to be able to do that. You're not allowed to use features of Python we have not studied yet, in particular loops and if statements. You may know how to use these things, you may guess how to use these things, you may look up on the internet how to use these things, but you can't use them in this problem set. We're asking you to solve this in a specific way because it will be good for your learning, not because it will be extra boring or take extra time, I promise. The goal of this problem is twofold, right? To be able to recognize patterns and then to be able to write functions that can combine together to produce those patterns. And so we recommend you spend some time thinking about, hey, this pattern has a lot of repetition in it. What is that repetition like? What are the patterns here really? And how can I identify that, like, maybe this is similar to this? Or maybe like these two together are similar to these two together. Or maybe even this is similar to this if I think about how I could, take that similarity and abstract it away. So that's the real skill we're focused on here. There's a diagram here, if you click this to expand it, that helps break down the different levels of similarity within the diamond pattern. And the recommendation here is that, only look at that after you've thought about the pattern on your own a little bit. There's another note here, we're almost through with this, that the problem has many solutions. So this is not one, like task 1 was, where we said, you must do X, Y, Z, W, Q, R, and do all of these things in exactly this way. This is a problem where we're saying you have some freedom. Here are your restrictions, they're rather tight, but beyond those specific restrictions, you can define 10 different functions if you want. You can have functions that are fruitful or not fruitful, that have parameters or not parameters. We don't care, as long as you get the job done and produce the correct output in the end. There's a particularly elegant solution, as this note mentions, that only has a single call to the print function. You don't have to do it. Totally up to you if you want to pursue that sort of perfect simplicity. But yeah, it's not even an extra goal. The extra goal is just to get it down to 5. Final notes. For a perfect score, right, this is another extra goal here, you can make no more than 8 function calls of any kind within the diamond pattern function itself, although you're welcome to make whatever function calls of however many number that you want inside of your helper functions. And this last one is just reminding you that to actually call a function, right, if you say diamond pattern, you're going to need to put parentheses to get it to display its results. Otherwise, it's not going to do anything. So that is the problem set to task 3 diamond pattern problem. It's one that's a little bit of a puzzle to figure out, but it should be productive in helping you understand how to leverage the power of functions to avoid repeated work. So it may seem tedious to produce this pattern that has so much repetition in it, but one of the cool things about computers is they can handle that for us, right? So that's it for me for now, and you'll see problem set videos from the other tasks in this problem set should be available as well.